What about others? Others, are you getting my voice or not? Actually, I stopped speaking. Oh, sir. From my side, it is okay. Okay, now the voice is clear. I'm verifying with my mobile. I'm getting my voice in my mobile also. Okay, now the voice is clear. Someone said 134. Okay, continue. Time is moving as it is moving. Are stay here. Are we same point, same time, same time. Suppose I had given some time period. as x. Same point origin O dash or O here to this after from the diagram. Uh, Drawing the same diagram. Air value what we are going to do? We are going to give relation between early substitute here. Get into two. Here what I mentioned time period here the point got the coordinates the coordinates the positions of the axis here. Want to find velocity of change of as we are What about others? What about others? But I am able to hear my voice in the mobile. I'm verifying through mobile also. Anyone please reply. I'm getting my voice clearly. It's okay. Shall I continue? Okay, now here started with the previous equation. Okay, so this was the equation I'm referring here. We are going to convert the coordinates into velocity. Got the positions. Now we are going to obtain the expression for the velocity. How can you get the velocity here? Velocity is obtained by differentiating the position with respect to time. That's why we are differentiating that. Now, what was the equation previously you got? Got x prime equals to x minus vt, or you can take the velocity along x-axis. Okay, that's the equation. Now, what we are going to do? We are going to differentiate this equation. Particular equation we are going to differentiate on both the sides. Now, what you will get? Let me go with another empty paper. Yes. Got x prime equals x minus xt. We are going to differentiate this in order to get the velocity. I will differentiate with respect to x time here. Same thing here. Towards the right hand side minus what we are going to get, dx by dt minus px is constant, so you can remove outside this product here, dt by dt. What happens? This will become 1 equal to 1. That's why you can write this as x by dt minus vx. Okay, this is the thing you are going to observe. Okay, now we are going to convert the same equation. We are going to rewrite the equation in terms of q and v. Now, particular equation, this part of the equation, left hand side, I am going to write this as prime. Okay, velocity in the second frame along x direction. Okay, now this was the equation we got. Now that is the thing we wrote in the here. Okay, here we got dx prime, okay, equal to x Now similarly, other two coordinates, other two velocities along y and z. Okay, here this is regarding the z axis. Will be obtained the similarity. Okay, there might be no confusion here. It is very clear. Simple equations. Started with the positions. We are converting the velocities by differentiating. What we are going to do? We are going to add all these factors. Okay, we are going to add all the three factors. What are the three factors here? X prime, y prime, z prime. Okay, here this is regarding the x-axis, so add I cap. Regarding the y-axis, add z cap. Thus, here you make this as a k cap. Okay, things we are going to represent there. Here, ux is regarding x-axis. Okay, next uy is regarding z-axis. These are the unit vectors representing the axis here. uz prime is regarding the z-axis. We are adding all the three velocities. Okay, and we will rewrite this particular thing as v. Okay, write this as u. Okay, now similarly, what we did here, we are going to add the factors regarding these three. Similarly, okay, so what we got here, got the addition here regarding the left hand side, regarding the velocity. Now you convert here, it is u here, you make the correction here, and here also it is u, like v, but it is u. Here this is regarding the movement of the frame on the s prime here. Okay, now just you are converting the primes as u prime. Here you need to write this as prime here because we are referring to the second frame. Prime here, prime equals to, here we are referring this prime equals minus, okay, that particular equation we are considering it as, let me rewrite like here, prime, this equation known as Galilean transformation regarding velocity. Equation represents Galilean transformation of velocity. Okay, now what was the thing? Started with the positions, okay, x, y, z, and you got the expressions in prime, I prime, prime, t prime. Converted this equation velocity by means of y prime, 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 prime by dt, y prime by dt, z prime by dt. These were the equations we obtained. Here regarding this, the time period is remaining same, so there is no need to have the fourth. We will get the velocities here. These are the velocities. Okay. Now what we are going to do? We are going to convert these velocities into acceleration. Get the accelerations. How you are going to get the acceleration? A equals to dv by dt. That is the actual thing. That is the rate of change of velocity gives the acceleration. Now what we are going to do? Differentiate these equations. Okay, these equations once again with respect to the time. Okay, now here you will get this as d by dt. Okay, differentiate again here, dx prime by dt. Okay, so what is the dx prime by dt? Back here, the dx prime by dt. First two, you got this. You got this particular representation. Now we are going to differentiate this. Okay, simply speaking here, differentiate this equation on both sides. Okay, we differentiate the velocity. Then what happens? What is the result of this particular differentiation? We are going to get this as the acceleration. Okay, along the x prime or the s prime frame. Okay, so the same thing here. Got the expression of acceleration in the second frame. Okay, now let us rewrite the equation. Some other color, I will change that. What you got previously, you got x prime. Okay, we differentiated this one respect to time and prime minus vx. The expression you got regarding the velocity. What we are going to do here, you represented this as here. I should write like this. Right here, prime now we are going to differentiate this factor, okay, on both sides. Prime on both sides we are going to differentiate with respect to time. X minus, okay. Here factor velocity is constant. As we mentioned earlier, this is a constant factor. Is a constant. If we differentiate a constant, what happens? Get a 0. Okay, that's why try to differentiate here. First factor here minus a dt, second factor. These are the suffixes. You try to refer here. These are the suffixes here. Minus this as 0. Here and okay. What you can write? The acceleration, rate of change of velocity, the acceleration in s prime frame. Now, what is this? The acceleration, rate of change of velocity in s frame or the first frame. Okay, so you can simply conclude here a x prime. Okay, this I am rewriting like this. The acceleration equals to again the acceleration in the first frame. Okay, here what is the conclusion? The acceleration in the second frame is equal to the acceleration in the first frame. Okay, similarly, now this is along the x-axis. What are the remaining? Can conclude here regarding the second and third regarding y-axis. Okay, remaining here third equation will be az prime az. Okay, now these three are the expressions for the acceleration. There is no change in the velocity and no change in the acceleration. We are considering both the frames. So here there is no possibility to increase the voice. I think I need to change the mic itself. Okay, so audio I can change. I mean, if I am listening, I can change the vary that particular thing, but I cannot increase or decrease the voice. Whatever the thing There might be a problem regarding the mic, I think. Okay, but I'm clearly audible in my mobile. I'm getting clear voice in my mobile. Okay, now it is okay means there might be a contact problem, I think. Thing is okay, now I will try to rectify in the next class. I am almost. Okay. Now here, that is the thing you need to identify. The conclusion of this part of the topic that the acceleration is remaining constant both the frames. There is no change in the acceleration. Okay, slower in the sense I'm a bit slower as I'm projecting the points to understand. For your convenience only, I'm speaking slowly. Okay. Now here this is regarding the acceleration. Now we will continue the topic. This was the previous conclusion. Now the remaining part, let us see today. Check where we stopped. Okay, so this was the previous point where we stopped. Okay, we are going to conclude this. Okay, we are going to conclude this. Now what is the remaining part? This is the remaining part. We need to conclude that the Newton's second law is invariant. Okay. So now what is the meaning of invariant? Invariant in the sense there is no change. Okay. Invariant means no change. Change. No change in what? In the Newton's second law. Why you are considering there is no change? Because we are considering two different frames. Okay. Now first frame is remaining at rest, second frame is moving. And we are verifying the Newton's second law. And what we have to conclude, even though the frame is moving with respect to the first frame, whatever the Newton's second law is there, F equals to ma, that should remain same even though the frame is moving. Okay. Then what will be the conclusion? We can conclude that then there is no variation. That we have to prove. Okay. For that, let us refer to the conclusion part here. We need to prove that there is no change in Newton's second law. What is Newton's second law? What we have to prove? We have to prove that F equal to ma, okay, and F prime equals to ma prime. Okay, both are equal. That we have to conclude. Okay, we have to conclude like this. Both the frames we need to get, simply speaking, that F prime or the force in the second frame will be equal to the force in the first frame. That we have to prove. Then what is the conclusion we are going to get? There is no change in the force or no change in the second law. That we are going to conclude here. Okay. For that, you consider this diagram. Now in this diagram, a little bit of change is there. Now in the previous diagram, we had seen that the frame is there somewhat here. Okay, we started the frame like this. Okay. Now here, there you got the three coordinates, three changes. Okay. Now x change, y change, and z change. Okay, the coordinates are changing there. Here, what I said, frame is moving only along the x-axis. Avoid confusion, we are considering only the change along the x-axis. Okay. Okay. Now refer back here, the same diagram, but the frame is there moving along the x-axis. It is moving only an x-axis here. That's why if you can refer to the equations here, the remaining two coordinates are same. Okay, x prime is equals to y, z prime equals to z. Okay, only the x prime is changing. Okay, what is the reason? We are considering the frame is moving along the x-axis. Okay, that's why you are getting this particular change. Okay, the remaining factors will remain same. Now these four equations altogether we call it as the Galilean transformations. You may get a short question to write the note about Galilean transformations. Means you need to write this short answer, this as a short answer. Just to take the frame here, S frame, take the S frame here, okay, and S prime, take the S prime, okay, and you take the movement of the second frame along x-axis, second frame along x-axis. Mention that it is moving with some velocity. Okay, this is a velocity, okay, moving with some velocity v. This is a constant velocity. Okay, v is remaining constant. If it is moving with some 2 kilometers per second or 2 kilometers per hour, that will remain constant, okay, throughout the observation. Now the same point here we had repeated with only one dimensional change. That's why you will get x prime equals to a change here. Okay, the remaining factors will be equal. Okay, now we are going to get the conclusion. We need to get that force in the first frame will be equal to force in the second frame. Okay. Okay, now here in the previous equation what we got, x prime equals to we got minus bx t. Okay. Now what we are going to do, we are going to get the force, from this equation. We will get the force. Now how can you get the force? First you get the velocity. So how you get the velocity? We differentiate this equation. Okay, with respect to time. Differentiate of this particular equation. Okay. Next, how can you get the acceleration? Acceleration will be equals to rate of change of velocity. Okay, d by dt of velocity. Okay. Now we are converting this. First we are going to get the velocity. So how we are going to get the velocity? Just you differentiate the equation. Now that is the thing we are going to do this equation. We are differentiating here with respect to time. We are differentiating x prime. Okay. This equals to, you differentiate this. Earlier we did this. Okay. Now here we will get dx by dt minus v. Okay. Now you go with the acceleration. Okay. Again differentiate this. Okay. Here what happens? As this velocity is there, it is constant. So if you differentiate that, you are going to get this as 0. So a constant cannot be differentiated, so you will get this as constant as 0. Now here this will be dx square by dt. Now convert this as a prime. Okay, acceleration in the second frame. This as the acceleration in the first frame. Now here prime. Okay, the acceleration in the first frame, the second frame will be equal to the acceleration in the first frame. Okay. Now the same thing we are going to conclude here. Okay, Newton's second law. Let us consider S frame here. Now in S frame what you can write, F equals to ma. Okay, so what you can write, actually what you got, acceleration is nothing but m into dx square, d square x by dt square. Okay, this is regarding the new first frame here. Now regarding second frame, f prime will be equal to mass of the particle is remaining same. Both the frame you are observing the same particle. The mass is remaining same. So a prime here equals to m into square x prime by d. Okay. Now consider this as equation 1. Okay. Now this as equation 2. Okay. Now you compare the equation as some A. Let us take it as A. Okay, let us take this as A. Okay. Now you compare equation A. Okay. Now 1 and 3. Okay. Now what is the thing here? A prime is equal to A. Okay. The same thing here we are going to conclude. A prime, if you write F equals to MA, okay, I can rewrite this A as MA prime. Okay. If you take MA prime means it is equal to F prime. Okay. So that's why we got a conclusion here. F prime is equal to F. Both the forces, okay, force in the second frame or S prime is equal to the force in the first frame or S frame. Okay. As the force is remaining same means the force is explained by the Newton's second law. The Newton's second law is remaining same. It is not changing. So not changing means we are going to use a word as invariant or invariance. Okay. So that is the conclusion of the topic. Even though the event is occurring in two different frames. Okay. Now if the frame is remaining constant, second frame is moving with a constant velocity with respect to the first frame. Here what we had concluded, we are getting force experienced by the particle as same. Okay. Now here what is the force? Force is given by the Newton's second law. As both the forces are equal, what you can conclude, there is no change. It is unchanged. Okay. So instead of unchanged means, what is the other word we are going to use? Okay, we are going to use the word as invariant. Okay, instead of unchanged, we are going to use this as invariant. Okay, so depending on the Galilean transformations, okay, we got these particular explanations. So now here, what is the conclusion? The Newton's second law is unchanged in the two frames. Okay, thus we conclude that Newton's second law is invariant under Galilean transformations. Okay, that is the end of the topic. So what we had learned here, it is the invariance of Newton's second law. Okay, now this is a small topic. The particle is there, a simple topic. Okay, just a small substitution. Nothing is there. Particle, the same particle we are considering. We are considering that particle is in motion. Okay, the particle is in motion means there is a force experienced by the particle. Okay, the particle is in motion means definitely there should be a force on the particle. So what is the expression of the force? It is the product of mass of the particle and the acceleration of the particle. Okay, now how can you give the acceleration? It is d by dt of velocity. Okay, next, how can you give the velocity? You can give the velocity as dx by dt. Okay, now what you can write here? You can write this as d square x by dt square. Okay, now the same thing we wrote here. Okay, the same thing we wrote here. Now here it is represented as r. Okay, the position in the 3 dimensions. If you take the 3 dimensions and x, y, z 3 coordinates, if you take all the 3 coordinates, you are going to write the r value. If you take only x axis, okay, then you will get only x coordinate. Okay, so how can you write r here? R can be given as x I cap plus y j cap plus z k cap. Okay, so that is a particle in the 3-dimensional space. Now if you take only 1 dimension, then you will get only x. Okay, you will replace r with x. Okay, you will remove these two factors. Take only this factor means it is only along the 1 dimension or the 1-dimensional particle or the particle in a single dimension. Okay, so that's why I am going to conclude this particular topic. What is the thing here? We are going to give a equation. Equation of what? motion of a particle. Okay, we consider this as the equation of motion of a particle. So how you are going to get this particular equation of motion? If a particle is in under motion means there is a force acted upon it. Okay, so what is the expression of force? F equals to ma. So how you are going to write a here is the d square r by dt square under 3 dimensions. If you're going to get the one dimensional equation, you can write that factor in terms of x. Okay, so let us see the last equation. Now here this is regarding the one dimension. Okay, this is regarding one dimension. What is the change if you want to convert this one into 3 dimensions? If you want to write in 3D, what is the equation? What we are going to write here? We are going to write this as f equals to m into d square r by dt square. Okay, that gives a 3-dimensional space because r is going to give the x I cap plus y j cap plus z k cap. Okay, if you got all the three, then this will be a 3-dimensional case. If you want only one dimension means substitute only x value. Okay, so now here this is a second order equation. You got only dx by dt, then that is a first order equation. Now the equation of force is there in the second order, d square x by dt square. Okay, as this is in second order, okay, we consider the equation of motion, okay, as second order equation. Here d square is there. That is the thing is going to give the expression of equation of motion of a particle. Okay, now if you are having any doubts, you can raise your hands. Please raise your hands if you want to ask anything. And in the next class, we are going to see another topic. We are going to refer spherical coordinates. Newton's second law or Newton's law, spherical coordinate. If you are having any doubts, you can raise your hands. Thirty members are there. Now I didn't had your attendance. I need to take the attendance also. First left the class. 103, you raised the hand. I'm unmuting you. 108 also, I'm unmuting.
హలో సార్. హలో
గుడ్ ఆఫ్టర్నూన్, చెప్పమ్మా.
సార్, ఇప్పుడు లాస్ట్ స్టెప్ లో దాన్ని టైం తో డిఫరెన్షియేషన్ చేస్తే యాక్సిలరేషన్ వస్తుందా సార్?
ఒకసారి రిపీట్ చేయ క్వశ్చన్.
మనం లాస్ట్ స్టెప్ లో టైం తో డిఫరెన్షియేషన్ చేయాలా సార్?
ఒక్క నిమిషం మళ్ళీ చెప్పు.
హలో,
ఒక్క నిమిషం. ఓకే, సో ఇందులోనేగా డౌట్. ఓకే, ఏం లేదు, జస్ట్
అది కాదు సార్.
ఫస్ట్ ఎక్స్ కోఆర్డినేట్స్ తీసుకురండి. ఓకే, నెక్స్ట్ ఎక్స్ ప్రైమ్ కోఆర్డినేట్స్ తీసుకొచ్చారు. లెట్ మీ గో విత్ దిస్ ఈక్వేషన్. ఓకేనా, ఈ ఈక్వేషన్ తీసుకోండి. So now we are going to convert the equation into velocity. Okay, so if you want to convert into velocity, so what we are going to do, we will differentiate this entire equation, both right side and left side. Okay, now what I will do, I will differentiate this equation with x prime here, and the same differentiation on the second side, minus vxt. Okay, now what you will get here, get this as dx prime by dt. Okay, this equals to dx by dt minus vx. Okay, so dt by dt means here you are going to get this as 1. Okay, next here this is a equation, this gives the velocity here. Now this is also a velocity. Now you got the velocity. Now what you are going to do, we are going to convert this equation into the acceleration. Let me go here, let me erase here. Okay, now let us see here. Okay, now here you got dx prime by dt equals to dx by dt minus vx. Now again you differentiate this factor. Again differentiate on both sides.
Okay.
By dt. Okay. Now this side also d by dt. Okay, the entire factor. You substitute the entire factor here. Entire factor. Okay. Then you will get the factor 1 and factor 2. Okay. Now here the first factor is there, which is constant. It is a constant. We mentioned this as a constant. So if you differentiate the constant, what happens? You will get this as 0. Okay. Actually, this is a constant here. Constant means it is going to give this as 0. Okay. Now here the first factor, what happens? It will become as d square x by dt square. Okay. Now if you are going to write the conclusion, here is once again. Okay, let us write the concluding equation to get the acceleration. Okay, now here what you are going to write as d square x prime by dt square equals to d square x by dt. Okay, now here this factor is equal to this factor. So what we are going to write, this factor is nothing but in the s prime, so I will write this as acceleration in the s prime frame, which is equals to this. Okay, what is this? This is the acceleration in s frame. So both the accelerations are remaining same. Okay, where we have started with the x here. We started with this, converted to velocity. Thereafter, we had converted into the acceleration just by differentiating those with respect to the time. Okay, now.
Okay, sir.
Okay.
ഇതിനെ പോകുന്ന ఓకే సార్
ఓకే ఓకే ఎవరో అన్మ్యూట్ చేశాను, నేను అన్మ్యూట్ చేశాను 103 అన్మ్యూట్ చేశాను ఇంకొకరిని. Anyone else? Something is there in the chat box. There notes. I will send in today's evening. In after 5:30, I will try to send. I'm planning to create a separate group for the applied physics WhatsApp group. So if I create that group, I will share in the main group. From there you can join. I'm creating only for the applied physics. There is a college. There any now till now we didn't got anything, but actually tomorrow is a national holiday. National holiday means there will be no classwork. Both I mean I'm expecting 3 days continuously. 3 days there might be holidays. 2 holidays, 25th and 26th, and thereafter 27th is Sunday. So we may have class on Monday, I think. Okay, meanwhile I will try to take the attendance. Take the attendance. If you are having anything, you try to send in the chat box.